So we are creating cell phones related data with their company name and also the establishment year with their concerned count in terms of ages. So creating data with company name, year and age of cell phone related information. So we are doing that process now. So for that, what we are doing is that what are the companies we want to take. I'm listing the companies: Nokia, Samsung, uh, Vivo, and iPhone. These are the related companies with their years of 1991, 1995, 2001, and 1985. And what is the ages are nothing but we are taking in terms of some years. The year is nothing but we are given the years, and now we are giving in terms of age, that is 24, some age 13, 53, and 33. So these are the ages. So this is the program information what we have given to you. So we are given the different company names with their years and with their ages what we have. Now we are asking you to create the information in terms of the related data that we want to extract. Okay, so that we are showing here. So we are been showing in terms of what is the program that we have to write. Okay, so what the program we have to write with the information given. So here we have to use the function called pandas. So by using the function pandas, we have to do everything and we have to justify that we have done this program with pandas and the related information is been printed. So and also with this one, another one I want is that it has to display information with year greater than 1985. So another information is that these are the informations what are given by me. Okay, the informations that are given by me are these things. That is, I'm asking you to create a company name and that is related with years and also it is related with age and what is the data that we want to establish. So the small changes I will be doing directly here. So I want to change in terms of name. So definitely I will be changing here in terms of name as Nokia, and another one I want to change is their Samsung. Another one I am changing in terms of Vivo and iPhone. So these are the changes what I have done, and the related names are being given. Now I want to change in terms of year. So I want to change year. Okay, year in terms of the numbers I'm changing here. So that is the thing what I'm doing. So no need of double inverted columns. So I'm changing in terms of 1991, 1995, 2001, 1985. And the ages that I related is nothing but 24, 13, 53, and 53. Oh, so we are not changing the ages. So I want to relate the information in such a way that I should get the data in terms of the related what I want to have to print it. So data pandas, which is data pair which we are given. Now I'm asking that I want to print in terms of year what we are having. Okay, so we'll run that program now. We will see what you are going to get. You can see here. So when we are running the program, we are getting the result of the entire information that Nokia at 1991 24, 98 Samsung 1995 13, like this all the information we got. Okay, in this information, the information which we are having should be changed. We are given in terms of age greater than 30 year. So thus it has printed out everything. So all who are having greater than 30. But originally the year is nothing but 1985, for example. That we have to give. So then only we can see the changes, right? So we will see the changes now. File save. Click on this. Then you can see now. See, you have the entire information, but the information which is of greater than 1985, only three are available. Those three are only printed. Okay, so that is the thing. We have not gone for some other. We have gone for the display of result as per the year. That is greater than 1985. Only those three are available, and those are being printed. So this is the thing about these three. What we are having, which is being shown. Next, we are going to start with today the concepts of your information of machine learning. That is in terms of the introduction part of the machine learning that we want to learn. Okay, so that we are going to start today. So we have seen the three types of the different types of machine learning. That is supervised learning, okay, unsupervised learning, semi-supervised learning, reinforcement learning. So in this one, we are going to start with the first concept, that is about your machine learning concepts, what we have in terms of the learning, what we are going to learn. So we are going to learn about supervised learning. So where in this supervised learning concepts, what we are going to learn is that we are going to learn in terms of the classification and regression. What are the different types of generalization, overfitting, and underfitting? What we have, and KNN. This is one type of method what we are having, and the classification regression using KNN that we are going to study. Next, we are going to study about the linear models what we are having. Okay, we have to learn about the sorry. We have to learn about classification and generalization and overfitting, and later on we are going to learn about KNN and classification and regression, and later on we are going to learn about linear models what we are having, and linear and ridge regression. We are going to learn about lasso. This is one type of a function, and later on we'll be learning about the linear models and support vector classifiers. Okay, that is of linear model support vector classifier, and also we are having about non-linear support vector classifier also, and naive Bayes classifier, and types of naive Bayes, and decision tree, random forest, and gradient boosted regression trees, and kernel realized support vector missions, and uncertainty estimates from classifier. All these are the contents what we are going to learn in the supervisor learning. What we are having. Okay, that is the thing. Okay, so these are the things what we are going to learn, which we are having to now. So we will be starting with this one. That is about your first thing, classification. What is the indication of classification? The classification indicates that it is in terms of two ways of classification. One in terms of binary, another one in terms of multi-class classification. Binary classification is nothing but you can understand very clearly with the name itself, binary. That is 0 or 1. Two classes only will be having. So that is the indication of that. So we'll be using either binary classification or we'll be using that in terms of multi-class classification, what we are having here. So we'll be studying the classification in terms of either binary classification of information or either in terms of multi-class classification, which is more than two classes. So that is the thing. So we can have some examples also. That is, iris is one type of is the general meaning of classification is being given here. So the general meaning of classification is nothing but we have been classifying in terms of two classes, that is binary and the which is having two. So best example we have given here is in terms of email classification which is available, where in the email classification we are having a spam related. Either if the information is present in the spam or if it is not present in the spam. So that is called a binary classification. Okay. So regression. Regression is a goal that we were being predicting a continuous prediction in terms of a number format. Okay, to predict the information in terms of your data. Regression is a goal to predict a continuous number format or floating number format of the information that you want to predict. That is, it is predicted in terms of continuous number or floating number formats in the data. So predicting the persons in terms of an annual income or anything, that is whatever it may be. Classification is nothing but those are shown in terms of the best example what we are showing for emails or anything, binary classification, or in terms of the multi-class classification. All these are shown here. So in the same way, regression is the goal to predict the continuous numbers, that is in terms of values or in terms of graphs. If we are representing, then it is the prediction is been done in terms of regression concept. It is a continuous number format of representation or floating the number format of representation. So generally, in the machine learning, we'll have the majorly two things. Okay, majorly we'll be having two things. That is in supervised learning to build a model for the training the data and also to predict the information for the data of unseen data after training. Okay, the main intention here in the supervisor learning is that if you want to build a model, when we are building a model, the model which has been built is been used for training, no? So for training the data, so then we are being able to make an accurate predictions. So that is been done here by using on the unseen data. Okay, mainly it has been done on the unseen data. So what we have been doing is that the model should be able to accurately predict the information on the unseen data. So this is able to generalize. Okay, the training set and also the testing set. So mainly in the supervisor learning, what we are doing is that we are building a model and we are training the model and we are accurately predicting the model whether it is able to predict the information or not after training only. So first we are training the model with the data. After training the model with the data, then we are giving a new data. So new information is given as an input or unseen data is given as an input for the model, and we are trying to identify the model whether the model is able to predict accurately the information or not. So that is called generalization of this one. So this is the generalization which is being called in the model. So the model is able to predict exact information means then we are able to identify and then we are able to say that your model is working perfectly. So we are training the model, then we later on we are testing the model. So this testing is nothing but on the unseen data. So what the data we have used to train the model, that data has been not used here. We are using some other data which is here unseen data or new data. That data has been used on the model and we are trying to identify whether it is able to predict the exact results or not. That is the intention of this one. So which we have explained already in the previous classes also. The same thing we are giving here. So this is called generalization. So what is the information here? For example, we are having an information of a customer who is older than 45 and has less than 3 children and it is not divorced. Then we want to buy a boat. Okay. So this is the best test data operation to predict the information of new data with a simply generalized model. So we are having the figure one with the information as per the customers which are being there as a features with the information of the customers which are there, and the figure two is nothing but who are being relevant to buy the boat. Two things, figure one and figure two. Figure one makes to say that we are having an information as per the features that we have. Okay, so the features are nothing but the customer should be with the age of 45, greater than 45, and should have less than 3 children, then and they are not divorced, then only they are eligible to buy boat. So that is the information of that. So as per that, the model is been trying to identify. So this is given, the figure one is given as an input. Okay, don't forget, figure one is given as an input for the model, and figure 2 is nothing but identifying the output who are eligible to buy boat. Okay, so that is the thing. So these two are being shown here. So when we are building the model, when we are training, okay, when we are building a model, when we are with the training, we'll get two problems. One is called as overfitting, another one is called as underfitting. Okay, so when we are building a model, so it is a too complex amount to have. That is nothing but when we are building that, if it is able to operate, the model is able to operate in such a way where it is able to generate the information where the training the model, okay, where the model is able to train better, but it is not able to generalize for the new data. So that is nothing but testing, right? So the model what we have trained, it is able to operate better, and the training has been done for the model in the better manner. We are able, the model is able to understand what is the input you are giving, but it is not able to work properly for the testing to get a proper prediction. It is not able to predict properly for the new data when we are testing on the model. then it is called as overfitting. Okay, then it is called as overfitting, as the model is able to work for the training to prediction purpose, but it is not able to predict properly for the testing. That is the thing. So then this is called overfitting of the model. Okay, right? So that is called overfitting. So the overfitting is the concept. What we are going to get here is that where we are able to train the model properly. We are training the model properly, but it is not able to test the model appropriately to predict the output what we want. Then that is called overfitting. Next, another one is that called as underfitting. This underfitting is nothing but where we are being giving an option in such a way that everybody is buys the boat but not able to capture the information training set of building the model working badly. Okay, there is nothing but the model is not able to work properly in data in the training the model. So when it is not able to work properly in the training model, then it is called underfitting. So in the first case, that is what we have shown here. This is your first case. In the first case, the model is being trained well but is not working perfectly. In the second case, the model is able to work not better in the training itself. Then it is called underfitting. That is the thing. Okay. So you are being able to have the data where the model is not working properly in the training, then it is called underfitting. If the model is not working properly in the testing, then it is called overfitting. So these two things should be avoided when we are preparing the model to work for training and testing. Okay, to work for training and testing, what we are doing there, the model that model has to overcome this training overfitting concept. The model should be able to overcome the underfitting concept. Both things have to be taken care in the model for overcoming the overfitting and underfitting, and it should be able to work properly to predict the output in the training and also to predict the output in the testing for unseen data. So these are the things which are important first for the supervisor learning for the data when we are working on that. That is the thing. So that is being given here. So we are being given with a graph to understand to you very clearly how it is being shown in terms of underfitting and overfitting and generalization. So this is the graph which is being shown here, which makes you to understand very clearly. Okay, the left side which is being given with model complexity and which is being shown with y-axis with the accuracy what we have. Okay, we are having the x-axis with model complexity and we are being shown with the underfitting and overfitting. So this is the point which we have underfitting and this is the point which we have a overfitting region. So this is the sweet spot. This sweet spot is nothing but a margin spot of region which is exactly help us to say our model is working in a better manner. Okay, our model is working with a better manner. So that is mean able to understand very clearly in the sweet spot what we are having. So this is a trade-off graph for the overfitting and underfitting which is being shown, and to identify whether the model is of too complex or for the training and testing and also for generalization. So that is being shown here, right? So the first concept of yours is that we are using a k nearest neighbors. KNN is one type of a more method or a technique which is used on the model for training and testing. KNN, K nearest neighbors. So this model is only one of the costs of training the model to predict and also to predict the output on the new data by using this algorithm that is called as KNN. Okay, by using KNN algorithm, we will try to extract the model to work on the training. After training the model, we will try to do the operation to extract the new output of testing with a predicted new data. So by taking the new data of prediction, we'll be operating on the information of this one, and we'll be extracting the information of the output what we want, whether we have been extracting or not. That we are going to see. So for that, we have been using this one KNA. KNA is nothing but which is being shown. The nearest neighbors of the data, which are closest neighbors, are being identified, and with the k neighbors of information what we are having. Okay, so the model is able to identify the data of training with the KNN to see that it is able to do the process of the data, and it is able to train the model or not, and after training whether it is able to predict or not. So these are the things which is been identified with the KNN. So we'll be doing on some data, and we'll be trying that whether it is been able to identify the classes or not. So for the machine learning models for KNN, the regression. So we'll take some sample data set and we'll implement on the data set using KNN, and we'll see whether it is able to classify or whether it is able to regression. Okay, right? That is the thing. So we are doing the prediction of this on the major classifier, right? So this classification is being done with the help of this information what we have, right? So we are been taking the machine learning model where the model is being used now with the scikit-learn, and we are been doing the classification which is called as the estimator classes. How many classes we are been dividing, that we are being able to classify. And for the KNN classifier algorithm, we are using a classifier which is called as neighbors classifier. Okay, neighbors classifier is being used to classify the data what we have, right? So we'll be classifying that with the neighbors classifier, and for that implementation of the classification on the sample data set we have been doing, and we have been classifying that, and also we are doing the regression. We are doing both of them. We are doing the classification, we are doing the regression. Both are being done there. Okay, to identify this. So to do this one in the Anaconda prompt. So what the intention here is that we'll be installing the Anaconda previously, and after installing the Anaconda, what we have to do is that we have to install pip, and we will see the new version of the current version is new version or not. After the new version, we have to give a pip install mglearn. So mglearn is nothing but machine learning. Okay, we have to install mglearn. It is a function which we have to install. So we'll be installing that in the Anaconda prompt. So you can have this prompt, this Anaconda prompt after installing in your laptops or desktop. After installing that, choose this one, pip install mglearn. So when you click on pip install mglearn, what we are shown here, it will collect the data and it will install in your information what you have been having. After installing this, what we are having, we can have the information on the data set. So we'll have a data set now. We'll take the data set of information and we will run a program by using the mglearn and on a data set, and we'll try to plot that data in terms of our two classes, that is binary class. One is of class 0, another one in terms of class 1. So that is the thing. So for that, we are taking a data set now. That data set is called as forg data set, and it is a data set what we are taking here is been implemented, and we are on the forg data set by using mglearn, and we'll try to run the program, and we'll see the result of the classification of the data and regression of the data, whether we are going to get the information or not. So that is the thing. So now we are going to start with one. So this is the first example. The first example is nothing but we are taking a data set now. The data set is made in terms of forg data set what we have. Okay, and this forg data set is being read in terms of two variables, capital X and small y. Okay, this capital X is your operating on the input on the forg data set. Input which has been operating, and small y is acting as your output to extract your information what you want. Okay, so that is the thing. So we have been importing mglearn, import mglearn, import matplotlib as plt as a variable which you want to work. So we are giving a function here to generate a dataset, that is mglearn.dataset dot make underscore forg. Okay, which has been there, right? So this forg dataset which has been available here is being used to plot the information in terms of two two classes, one in terms of class 0, another one in terms of class 1. Okay, right? So that is the thing we are been having in terms of mglearn dataset of forg. So this dataset which has been operating here is having two classes to segregate, class 0 and class 1. So that is being given in terms of plt. So plt in terms of class 0 and class 1 with location equal to 4, and plot x label and y label, that is first feature is given the name x labeling, and second feature is given name with the y labeling what we have, right, which has been there. So that is being shown here, and we are asking you to print x shape, that is format X shape. So this is the program what we are asking you to write to do for the data set of for the data set, and we are asking you to plot that one. So this is nothing but location equal to 4. So that I will show you why we have written that. So this mglearn discrete is nothing but x colon 0, x colon 1 comma y. So we are asking you to plot. So take this one as your all the variables colon is here is nothing but means to say that take all the values. Okay, take all the values here of 1. So differentiating all the values of 0 and 1, and those are being printed to be printed with the help of y as the output variable. So input variable of x with output variable of y, we are trying to extract the outputs what we want to have, right? So we will write this program in the spider tool only, and we will try to extract the output. Right now we are been going for the spider tool. So in the spider tool only, we will try to extract the output. Right. So we have taken here in terms of now another program. This program is consisting of the data set of forg data set, and you implementing using mglearn. So we are writing this program, we are using that, and it is running the trying to run the program. So after running the program, we are getting the result. You can see. So it is being shown here. mglearn import matplotlib and x comma y mglearn dataset make underscore for, and we are taking the classes scatterplot. We have asked to print mglearn scatterplot x colon 0, x colon 1, y, and plot legend and location 4. What this indicate location 4 is that 1, this is location 1, 2, 3, and this is location 4. In the location 4, we are asking you to give the legend, that is the tag of this one. Okay, class 0 with one color and class 1 with one color, and that has to be printed in the output only. So that is in the location 4. So the location 1 is this one, 2, 3, and 4. Okay, 1 is on the top left corner, second on the top right corner, third on the left bottom, and fourth on the right bottom. So this we are getting here location 4. So plot x label and plot y label, that is we are given the name for here very clearly, first feature, second feature, and we are asking you to print x shape. So we are asking you to print the data set of x shape. So it has printed. So this blue color is of class 0 and red color is of class 1 what we are having. So like that it is able to print this one. So this is the thing what is being printed. So here we have not yet used anything k nearest neighbor. Now we are going to use knn for this one. Okay, so we are going to use knn for this one to print the data, right? So what we are going to use here is that we are going to use here a function mglearn dot plot dot plot underscore knn underscore classification in terms of n underscore neighbor equal to 1. Neighbors equal to mglearn plots dot plot underscore knn underscore classification n underscore neighbors equal to 1. So after writing this statement, we'll run the program. So what is the main intention? See here in the output itself very clearly. In the previous output, you have been classifying only in the binary classification, that is class 0, class 1. And here we have been dividing the information in terms of binary only, class 0 and class 1. Now the points which are near to the values, that is, for example, it has been stretching, no, it has been connecting 2 points here, which you can see. So those two values are nearer values only. Here you are having 11, and this value is 11.2 or something. So these two are nearest values. Those two are connected. Here you are having these two values nearest values. Those two are connected. Here you are having 10. This is maybe some 10.1 or 10.2 or something. These two values are connected. Here we are having the two values which are being shown. Way nearest neighbors. No, those are not nearest neighbors. There is some difference which is there. Okay, which is being there. So that's these are nearest neighbors. Those are connected. So the nearest neighbors for one nearest of one value, one nearest neighbor, those are connected. You can change that. If you want to have the nearest neighbors of three values which are there, if you want to connect, you can change them. Just change the value to 3. If you change that and if you run the program, if you see that, now you can see three values are connected. Now your justification is satisfied. Three nearest neighbors are being connected. Three nearest neighbors are connected. So all these things. So that is the thing what happens here. Okay, right? So this is about KNN, what we are having, right? So this is about KNN, what we have. So this is the class of today. Tomorrow we'll see about KNN with regression. And tomorrow you'll have an assignment to do, which you have to run this program in your laptop, and you have to upload this graph, okay, in the Google form what we are giving to you, right? You have to run the program and you have to upload the graph in the Google form tomorrow what we are giving to you. That is important. Okay. So we'll be sharing this presentation to you today itself, right? So there is a thing. Okay. Thank you for today class. Tomorrow we'll meet the class in KNN with regression concept. Okay, right.